वेलकम माय डियर स्टूडेंट, वेलकम अगेन इन माय चैनल फिजिक्स जैन। तो आज we'll shall study about the thermal expansion of solid, liquid and gas, and its important theory or points has to be remembered for the coming JEE or NEET exam as well as the CBSE or ICSE class 11 or 12 exam. Okay, so thermal expansion, today's topic is thermal expansion. Thermal expansion. When some amount of heat is added to any substances, it increases along lengthwise, area wise or volume wise. So the molecular attraction of solid is greater than liquid or gas. The molecular attraction of gas is least and the molecular attraction of solid is greater or largest. Okay, so expansion, any type of expansion is inversely proportional to the molecular attractional force. Where attractional force is large, expansion is least, and where attractional force is small, expansion is large. So in this case, the expansion of gas is highest, then liquid and then solid. Solid has three types of expansion. Solid can expand along lengthwise, so it has linear expansion. It has linear expansion. It's elongated or expand along area wise, so it is called superficial expansion. And it expand along volume, so it is called volumetric or cubical expansion. Suppose a rod of length L or L0 is given some amount of heat and its length becomes L0 plus delta L. So the coefficient of linear expansion if alpha, then we can say that alpha is equal to change in length, that is delta L, by initial length multiplied by change in temperature. Alpha equal to del L by L0 delta T. Again, if any solid increase along, suppose this is a plate or disc, if it is heated, then its area is increased. So the superficial expansion, coefficient of superficial expansion or areal expansion is given by beta equal to del S divided by S0 delta T, where S0 is the temperature, initial temperature or temperature at 0 degree centigrade. Similarly, gamma, the coefficient of volume expansion, is given as change in volume, that is delta V by initial volume multiplied by temperature change. So alpha, beta, gamma is the measure of expansion. The unit of alpha, beta, gamma does not depend on the length, area or volume. The unit is degree centigrade -1, degree centigrade -1 or Kelvin -1. The relation between alpha, beta, gamma is alpha is to beta is to gamma equal to 1 is to 2 is to 3. That is percentage change in area. Percentage change in area must be equal to percentage change in length, multiply by 2. or percentage change in volume equal to percentage change in length multiplied by 3. Percentage change in volume equal to percentage change of length multiplied by 3. So, there are 3 types of expansion of solid, but liquid and gas has only volume expansion. That is, they does not have alpha or beta, only take the gamma. Liquid has 2 types of expansion. One is apparent expansion. Liquid has 2 types of expansion. One is apparent expansion. And other is real expansion. When liquid is heated, suppose this liquid is heated, not only the liquid but also the container expand. So, suppose there are some liquid is filled in this flask and the level of liquid is P. So, P is the level of the liquid enclosed in this container. Now, suppose when the heat is supplied, at first the flask is expand greater than liquid. So, when the flask expands, the liquid falls down to the point Q. After this, when we continue the heat, then the expand of liquid is more than flask. So, the liquid is expand from Q point to R point. So, in this case, the expansion of vessel or flux equal to PQ, because when the vessel expands, the water comes from P to Q. So, real expansion of liquid is liquid falls down to Q, then initiate from R. So, QR is the real expansion. And apparent expansion equal to, our eye cannot understand the process that the liquid comes from P to Q, then goes to Q to R. Our eye can only understand that the liquid was first at P, then it goes to R. So, the apparent expansion is PR. So, there are 3 types of coefficient of volume expansion. So, there is a relation between 3 types of expansion, that is, real expansion must be equal to apparent expansion plus vessel expansion or expansion of vessel. So, if real expansion is denoted by gamma R, this is must be equal to gamma A plus gamma B. So, this is the relation between 3 types of expansion. Where if the liquid has volume V0 at some temperature like 0 degree centigrade, and after delta T temperature change is volume is V dash, suppose it is V, then V dash equal to V into 1 plus gamma R into delta theta or delta T. V dash equal to V into 1 plus gamma R into delta theta. This is the relation between three types of expansion. So the gamma R becomes V minus V0 by V0 into delta T. Gamma A becomes gamma A becomes V dash minus V0 by V0 into delta T, or gamma vessel V becomes V double dash minus V0 by V0 into delta T. Okay. Now we go with three types of expansion. We know that expansion. There are two types of volume coefficient. One is at constant volume and constant pressure. So the gases, next we go with the expansion of gas. Gas has two type of volume expansion. Gas, we can discuss the solid and liquid and gas. There are two type of coefficient of volume expansion. One is volume expansion or coefficient. You know that coefficient of volume expansion, coefficient of volume expansion at constant volume, which is known as gamma V, becomes Pt minus P0 by P0 delta T. Coefficient of volume expansion at constant volume, and other is coefficient of volume expansion volume expansion at constant pressure, that is pressure does not change, constant pressure. So gamma P, here the suffix denote that it is constant. Here V means volume constant, P means pressure constant. Vt minus V0 V0 by V0 delta T. We can next show that the value of gamma P must be equal to gamma V. It is 1 by 273. Okay. Now we go with some application of thermal expansion. But before going to application, we can denote the relation between the density and the temperature. So suppose at any temperature theta, the volume is V and the density is rho. At some temperature theta dash, where theta dash becomes theta, that is the liquid is increased or gas is in temperature, the temperature of liquid or gas is increased, then at some temperature theta dash, volume become V dash and density is rho dash. We know that the volume V is inversely proportional to density. So V by V dash equal to rho dash by rho. Now we know that V dash equal to V into 1 plus gamma delta T, or we can say that delta theta. Delta theta means theta dash minus theta. So here we can show that V by V dash equal to rho dash by 1 plus gamma into 1 plus gamma into delta theta. So rho dash by rho equal to rho dash by rho equal to 1 by 1 plus gamma delta theta. That is rho dash equal to rho by 1 plus gamma delta theta, or we can say it that rho dash by rho into 1 plus gamma del theta minus 1 nearly equal to rho into 1 minus gamma delta theta. As delta theta is very small, so we can approximate 1 plus gamma delta theta equal to 1 minus gamma delta theta. So when temperature increases, volume increases but density decreases. Okay. Suppose a body is immersed into a liquid, its upthrust is given by some quantity, that is V sigma G. V is the volume of the substance, sigma is the density of water or density of liquid in which it is immersed, G is the gravitational acceleration due to gravity. Now if the temperature is increased, then V becomes V dash, sigma becomes sigma dash, and G. Okay. So it can be said that V sigma G and V dash sigma dash G, from the relation V sigma G and V dash sigma G, we can conclude that when temperature increased, upward force, we can say that upward thrust or buoyancy, upward force decreased and apparent weight of body decreased. You have to write this in your copy, okay? Okay, this can be explained by numerically. If this is, we know that this is at upward thrust TH and this is at TH dash, then put the ratio TH by TH dash and V dash equal to V into 1 plus gamma delta theta, sigma dash equal to sigma into 1 minus gamma delta, then we can say that we can reach into this conclusion. When temperature increase, upward force decrease and apparent weight of the body, apparent weight of the body increased, not decreased, sorry, my mistake, increased. So when temperature increased, the upward thrust decreased, and upward thrust decreased, apparent weight increased. Okay. Next we go with some application of thermal. Next we go with the application of thermal expansion. The first application of thermal expansion is bimetallic strip. Bimetallic strip. Bimetallic strip is nothing but two types of material, equal length, having equal length, two types of material are connected in such a way that when temperature increased, it bends. Okay. So number one is bimetallic strip. Suppose this is a bimetallic strip made of copper and aluminium. Okay. So when temperature is increased, then it bends due to unequal coefficient of linear expansion. Here the bimetallic strip bends with the metal with greater alpha in convex side. So here this is convex side and this is concave side. Okay. So in convex side, the metal with greater alpha, that is aluminium has alpha, aluminium alpha is greater than copper alpha. So in the concave side copper exists, in the convex side aluminium exists. So with greater alpha is always in the convex side, or it is called outside. Okay. A question is asked in NEET exam, that aluminum and steel, there is a bimetallic strip of aluminum and steel. When heated, then the steel is at convex side or the steel is at concave side. So if there is a bimetallic strip of aluminium and steel, so alpha of aluminium is greater than alpha of steel. So if this is bends along this direction, so along concave side exists steel and along concave side or outside exists aluminium. So you can say it according to the option of the question. Okay, it is used in electrical circuit such as when fire alarm, when alarm is rang when there is happening to fire or dangerous fire occurred. So bimetallic strip is an example of thermal expansion. Number 2 is simple pendulum. Simple pendulum. The time period of pendulum is given by t equal to twice pi up root under L0 upon G. When temperature increase, then its time period is theta, the time period t at some temperature when the temperature is theta. Okay, when the temperature is theta. When we increase the temperature, its temperature becomes theta dash. Temperature becomes theta dash, where theta dash greater than theta. So T dash equal to 2 pi root under L dash by G, or it is said that T dash equal to twice pi, L dash becomes L naught 1 plus alpha delta theta by G, where delta theta becomes theta dash minus theta. If we take the ratio that T dash by T, then it becomes 2 pi cancel, L0 cancel, then it becomes root under 1 plus alpha delta theta. So it can be written as 1 plus alpha delta theta to the power half, but as delta theta is very small, so it is nearly equal to 1 plus half alpha delta theta. So the change in time period, change in time elapsed per unit time, that is T dash minus T divided by T, change in time per unit time, must be equal to half alpha delta theta. Now loss of time in a day, loss of time or gain of time in one day, that is T dash minus T, T dash minus T becomes half alpha delta theta into T. Now in one day T is 86400 second, 86,400 second. So if we cut it, so it is 43,200 alpha delta theta. Write down it. Change in or loss or gain of time in one day is 43,200 alpha delta theta. Alpha is the coefficient of linear coefficient of simple pendulum. Now there are three cases. Okay, there are three cases in which the theta becomes greater than. So when theta dash greater than theta, then T dash greater than T, T dash greater than T means when time period is large, the watch or pendulum will go slow, watch will go slow. Time greater means watch is getting slow, or loss of time occur, loss of time. Number 2, theta dash less than theta means T dash less than T, that is time period छोटा हो गया है मीन्स watch will go faster or gain in time. ओके, सो अगर टाइम पीरियड इंक्रीज हो जाता है इसका मतलब कि घड़ी फास्ट नहीं चलेगा, स्लो हो जाएगा, इसको ख्याल रखना. ओके, नेक्स्ट वी गो विथ टुडेज टॉपिक इज scale reading. Scale reading. Scale reading. Suppose when a scale is only increase, when the length of an object is measured by a scale is L0. Measured by the object is L0. So L0 is called its true value. Its true value. True value of object. Due to increase in temperature, suppose scale is increased. So if scale is increased, then its value is decreased. समझ में आया? Because scale increased हो जाएगा. अगर या 0 या 10 होता तो जो ऑब्जेक्ट का डिस्टेंस है, सपोज ए रॉड और वायर और किसी भी स्टिक होता तो उसका जो वैल्यू है वो है 10 सेमी. अब इंक्रीज हो गया है तो यहाँ पर 0 यहाँ पर 10 है तो यहाँ पर होगा 8. सो यहाँ पर होगा 1. सो 1 to 8 मीन्स 7 सेमी. सो द लेंथ इज, इसको कहते हैं स्केल रीडिंग. सो द स्केल रीडिंग हो जाता है 7 सेमी मीन्स इज डिक्रीज. सो true value equal to scale reading. SR means scale reading 1 plus alpha theta minus theta 0. Theta 0 is the increased temperature. Okay. In the second case, when the length of the scale is decreased, the reading is increased. Okay, the reading is increased. So true value equal to scale reading. SR means scale reading into 1 plus alpha theta. You can say it as 1 plus alpha theta. Here only scale increased. Only expansion of scale is considered. Expansion of scale is considered. But in the second case, when object and scale both increase, both expand. So here both object and scale is increased. In this case, the formula is measured value equal to true value into 1 plus, sorry, true value into 1 plus alpha 0 plus alpha s into theta or delta theta. 1 plus alpha 0 plus alpha s into delta theta. Alpha 0 is coefficient of linear expansion of object. Alpha s is coefficient of linear expansion of scale. So we have taught all the important theory related to NEET or JEE. In the next day we will go with numericals of the thermometry and coefficient and the thermal expansion. So guys, if you like my video, please subscribe my channel. देखते रहिए, जानते रहिए. And for today, good night and thank you very much for your support.